All right. I see we are slowly taking our places. Okay. So, I would like to welcome you back to our experts workshop. Before we start with our first session of the day, a couple of organizational announcements. First of all, I would like to let you know, because this, it seems several participants were not aware of this, that the presentations have been made available at the beginning of the week on the Experts Workshop website. Now, you will see that some are missing because we didn't have all the presentations at the beginning of the week. But obviously, after the workshop, they will be updated with all the presentations and also the latest versions of the presentation in case there were changes in between. But for most presentations, you will be able to find them on the workshop website. Then I hope yesterday you had a good evening, that those of you who were at the workshop dinner enjoyed it, and that those who were not also enjoyed whatever you were doing. I just wanted to share that I found out why it's called Five Flies, and it's less disturbing than I initially thought. So it's quite easy. It's they have 5 rooms because it was an old house with 5 different rooms, and the first owner of the restaurant, his last name was Flies, Vliegen, so Mr. Flies, and that's why it's called Five Flies. So nothing to do with potential insect infestation or anything like this. Just to clarify. All right. Now that has been dealt with, we can start with the program for today. The first session of the day is on the new releases of the SDMX standard. We're going to talk about SDMX 3.0, 3.1, 3.2, and we're going to stop there. The session is chaired by Bianca from the BIS, whom you already had the chance to see over the course of this event. So Bianca, I leave it to you to start us off with this session. Thanks.
No? Yes, no, yes. Thank you, Luca. Good morning, everyone, and welcome to the session on new releases of SDMX that I'm honored to chair. So Luca already more or less said what I intended to say. Yes, it's about the latest development in SDMX and the upcoming development, as well as some technical implementation. Maybe just to mention, there will be poll throughout the entire duration of the session. The QR code is always the same. If you connect now, you will see no active question. If you manage, you can stay connected, and I will open the questions. Otherwise, I will put the QR code again, and you can reconnect. So for each of the presentations, we will have a couple of sessions, and I hope we have enough time at the end to discuss the results altogether. This is the program of the session. I think most of the presenters were already introduced in the past days, so I'm not gonna introduce myself again, of course, and you should already know Brian because he chaired the session yesterday, he presented yesterday. So yes, I will now be co-presenting with Brian some results on the IFC survey that we already started presenting yesterday, now focusing on SDMX 3.0 in particular. So Brian, you can join me if you want. While I wait for the slides, I already spoke about this survey yesterday. We launched the survey among IFC member central banks from March to August 2023. We had 52 respondents, and the set of the questions was focused on SDMX 3.0 adoption status and the possible need of support for specific tools for SDMX 3.0. So maybe to start with something which is not related to the survey, but to SDMX 3.0 in general. And probably many of you in this room know better than me what were the features introduced in 3.0. But just to recap, after 10 years of experience with SDMX 2.1, the information model was enhanced with some features required by use cases, and there were some breaking changes, as well as some old format which was deprecated, such as the SDMX EDI format, some breaking changes in the REST API, and new enhanced features. And SDMX 3.0, in general, I just wanted to connect it to the vision of the 2025 roadmap, is a direct response to the goals of the roadmap and the 4 pillars of implementation, simplification, modernization, and communication. And also something that I wanted to take from the roadmap, because we will focus on this later, Brian will present some results, is the need of follow-up actions to implement tools and resources in order to support every new version of the standard. And this is something on which we also wanted to focus the survey on. We wanted to see if the enhancements were supporting actually the users enough, or if there are any gaps. Now I jump in some results from the survey. We asked the respondents which SDMX version are you using. I don't know if this is surprising or not, but most respondents mentioned that they are using 2.1, either alone or in combination with SDMX 2.0, which maybe suggests that, yeah, of course, migrating to a minor version with no breaking changes is easier. And in particular, 3.0 adoption among the respondents, which again are just IFC member central banks, was very low. In particular, the numbers that you see here are not only institutions using SDMX 3.0, for example, in production, but also those that are evaluating it or testing it. One consideration that we had is that the versions used are again influenced by the reporting requirements of international organizations. So if there's no mandate to disseminate or collect a dataset modeled in 3.0, maybe there is no business case to do so. We asked then what are the blocking factors for which you are not using yet SDMX 3.0. This comes with no surprise, most of them are not using it, so 92% of the respondents highlighted at least one factor that it's blocking them to implement it. And first in the line is the lack of resources. And the second one, as I was mentioning before, what is also suggested by the current state is that there is no business case for them to migrate to a new version, so they are not doing so yet. Then I grouped together 2 reasons that concern tools, in particular, both the need to adapt internal existing tools to a new version, that together with breaking changes can be a challenge. And also, it was not mentioned as much as the other ones, but it's still regarding tools, the lack of support for SDMX 3.0 in open source tools. And Brian will shortly talk a bit more about this. But just to expand a little bit on these 3 main blocking factors, the lack of resources. Maybe there is not much direct action that can be done there, but there is a lot of indirect action. So the need of resources can be minimized, for example, by adapting open source tools to 3.0, and also adapting the guides and providing e-learning tools maybe, or community support. Regarding the business case, as I was already mentioning, I also mentioned it yesterday in the other results of the survey, there is a demand-driven effect. So the central banks very often report what they are asked to report, and if what they are asked to report is not modeled in a specific version, then probably there is no business case yet, which could just be an idea to promote 3.0 in new pilot exercises if there are data sets that can be collected and can benefit from the features of 3.0. And the last group of blocking factors is the adaptation of tools to accommodate SDMX 3.0, on which Brian will tell you more.
Okay. Thanks, Bianca. So that's the state of play. This is looking forward. In 3 years, you can see the SDMX 3 implementation or planned circle on the bottom of the Venn diagram is looking a little bit better than the current state. So 24 out of the 36 central banks intend to migrate to SDMX 3.0 in 3 years. Nevertheless, there's still 33% of the institutions satisfied with 2.1 and don't foresee migrating. Everybody that's using 2.0 intends to migrate, probably not surprisingly to a certain degree. There's backward compatibility issues with EDI that must be, so the EDI format needs to be translated. I don't know, maybe you can know a little bit more about that. I'm not familiar with the use of the EDI in the central bank situation, but so there is intention to move to SDMX 3. The linkage between knowledge and adoption plans is actually quite strong. So the numbers in the chart represent all central banks that either are extremely, very, or somewhat knowledgeable in SDMX. The pink bar represents intention to migrate to 3.0, and the bluish green or teal bar, I guess, represents not planning to migrate to 3.0. And as you can see, in all processes, I'm not sure if it's readable or not, but in all processes, the intention to migrate is higher than the intention not to migrate, except in one instance, and that's reporting, which is the third group of bars from the right. And again, as Bianca had already mentioned, and we mentioned yesterday, a lot of this can be attributed to the demand-driven model. So and this is what was mentioned in the lack of business case comments from the central banks. If the reporting agencies aren't asking for 3.0, we have no reason to migrate to 3.0. So, the various tool producers were quite generous in providing their current status and migration plans for 3.0. And as we showed in the ecosystem concept yesterday for SDMX.io, organizations are using multiple tools, and there's dependencies in that model. So the good news is that for the core libraries, which is the first layer of those dependencies, SDMX source and SDMX core, the state of SDMX 3 support is actually quite good. I guess, again, as shown yesterday, the next layer of support or dependency would be SDMX RI and FMR. And again, the current and planned state for SDMX 3 adoption is quite good. And there's 2 slides here, so there's some more tools on the next slide we'll flip to in a second. So most organizations have 1 to 3 year plans for strategy and budget and so forth, whether it's for transitioning to 3.0 in their data strategy or whether it's in the adoption of SDMX. So for the other tools that are here, I just use this as information for informing your own planning cycles. So there's the iStat toolkit here and the SDMX converter. And then we have the various ILO tools and .stat suite. You'll notice that the matrix generator from the OECD is not here, and that's because, as was presented yesterday by Glenn, the intention is to eliminate that tool, and it's going to be integrated as a new tool within FMR. And it'll be SDMX 3 compliant, not as part of the MVP, but shortly thereafter. And as also was noticed in the last couple of days, most of the new tools that are being released, such as PySDMX, et cetera, are all coming out as being, again, SDMX 3 compliant, either as part of the initial release or as part of the roadmap to be available shortly after the initial release. So support for SDMX 3.0 and tools varies quite a bit, but the base layer of dependencies, it's quite strong. So if anybody is creating new tools or wants to migrate their existing tools, everything is there that they need. As far as the interesting thing about SDMX 3 adoption barriers is they're exactly the same as the initial adoption barriers for organizations considering adopting SDMX. There was, aside from the business case point, there was no difference. It was lack of resources, lack of knowledge, support and tools. So I think that needs to be taken to heart by everybody, both when we're looking to launch and release new versions of the standard, because again, nothing moves without these core elements to help organizations make that change. I think promoting SDMX 3 in pilot exercises from the IO side could be very helpful. And there's definitely a need to migrate the IOs to migrate the existing data flows off of 2.0 and at some point off of 2.1. I mean, as we saw again in the SDMX adoption plans of organizations, a lot of them adopt SDMX for reporting first and then extend that to other parts of the data processing lifecycle and to other domains. So if the IOs are asking for SDMX2, that's the basis upon which organizations have to consider extending SDMX into the rest of the organization. So that affects the tools that they have available to use. It affects the capabilities of SDMX that they have available to use. It's really a handicap. So I think we need to help the organizations by trying to move away from SDMX 2.0 because that will drive SDMX adoption capabilities throughout the rest of the organization. And I'll let Bianca introduce the slider.
Yes, it's probably not yet active, so I will launch it and we can test if it works. But in the meanwhile, we do have 5 minutes for questions, if there are ready questions. Yes. Is there a microphone?
Should we leave the Slido up or leave it
yeah, maybe, yes, please. The Slido is going. There is time to answer it, not necessarily now. We can start taking questions, but in the meanwhile, everyone can answer the first set of, you should see 3 questions. Yes, please.
So, yeah, thank you for that. I'm just wondering, like, in there, maybe a bit more detail of, like, how much do they understand about XMX 3.0 versus 2.1? Because in the end, I mean, XMX 3.0 is just introducing new features. So what's in their mind when they're answering these questions? It would be, I don't know if you've got that information, but it would be interesting to know.
I agree, it would be interesting to know.
Okay. Because it's not necessarily a question of just adopting XMX 3.0 versus 2.1. It's XDMX and migrating tools, and sometimes this fear of, and we talked about it in the breakouts, you know, this fear of sort of migrating all their tools. They've invested a lot already. So I'm just wondering if this is sort of in their minds as well. So thank you.
Yeah, I mean, in a survey like this, there's no way to assess that. Okay, so, but yeah, it's good points.
Yeah, thanks for the presentation. So it's just a point on the matrix generator, because yeah, Brian, you said yeah, the plans are to eliminate it. I think it's a bit early days to say that because, of course, you know, we're still transitioning, still got the funding gap. So, and it really depends what happens, right? Because I mean, moving forward, even after the integration into the FMR, well, not everyone may have access to the FMR, right? So, so yeah, I mean, it really depends what happens, you know, when the integration happens, and you know, see what the call is for SDMX3 in a tool such as a matrix generator. So we'll see there. Thanks.
Thanks, David. And as you said, as it was clear from yesterday, the matrix generator is your baby, so we understand.
There was one more question in the front, Matt.
Thanks, and yeah, thanks, Brandon. It's really interesting statistics. And on the comment about the tools, because of course tools are required to implement the standard before people can use the new features. In the technical working group, we've discussed and agreed that when the technical working group is making changes to the standard to introduce new features, like the new feature to support horizontally complex DSDs, that should first be implemented in some software, not necessarily in a tool, but at least in the software to demonstrate it can work. And then when the standard is released, it more quickly gets adopted into the tools. Because that's the kind of ambition now of the TWG, to actually go through that process, rather than do a big release and then have to quickly implement all of the new features.
Yeah, I think that there's some communication. I mean, it's a great point. I totally agree. There's some communication that could be done around either when there's new features introduced in the version of the standard, either what problems is it solving or what benefits is it introducing that can't be done today. You know, so just to sell the standard a little bit or to sell the change, because without the reason to change, you're just changing to stay current. If you have a reason to change, you can actually drive management, drive budget, drive priorities, and actually move the organization.
Yeah. So that then becomes the communication part of the change.
Exactly.
Yeah. At least from the tooling part, that you know we should be slightly quicker.
Yeah. I think we'll see that come out in the Slido poll.
Yes, exactly. That's what I wanted to mention. We can see what the audience thinks as well. Thank you, Matt. We could have time for one more question. I think I see no raised hand, so thank you, Brian. Thanks a lot. And our second presentation of the day is by Abdullah. You can join us here on the stage. You were already introduced yesterday. I think everybody knows you, but yeah, Abdullah is a statistician at the United Nations Statistics Division, and he's highly specialized in SDMX. I think he doesn't need to be introduced the second time. He will present SDMX 3.1 horizontally complex TSDs. Thank you, Abdullah.
Yes, I'll make use of the whiteboard if we have. Do we have it? No. Okay. If
Do you have
not,
something?
I will just have to speak really loud. Anyway. Yeah. So thanks, Bianca. So we're going to talk about SDMX 3.1 and its standout feature. Support for horizontally complex data structure definitions. I mean, to begin with, let me start by saying that the SDMX 3.1 is now undergoing public review. So, if you like what you see, you can comment accordingly, and if you don't like what you see, you may wish to skip your comments, or you may wish to write them. It's up to you. Anyway, so. Multidimensional data sets. What is a multidimensional data set in the first place? It is a data set that has many dimensions or many breakdowns. And this dealing with multidimensional data sets is a very long-standing problem. I first encountered that when I started working on the UN demographic database back in 2005. And that had nothing to do with SDMX. It had everything to do at that time with the relational database structure. Bianca, please keep me in check. When you see that I have less than 5 minutes left, please signal to me, otherwise I might be carried away. Yeah, so. And a large number of dimensions, it creates difficulties, it creates complexities at several levels. One is that it is fundamentally relatively difficult to deal with highly multidimensional data sets in the first place. And secondly, because when you have a lot of dimensions, there is a high likelihood that you'll have even more. And adding a dimension, updating the dimensional structure, whether you are working with a relational database or SDMX, is always expensive. And some of the ways that people have addressed that issue is by creating horizontally complex structures with many pure concepts, vertically complex structures with pure dirty concepts, and many pure structures and tables. And this is where I would appreciate a marker. Oh, no. So why do we have that problem in the first place? Well, it's because because the structures that we are working with in relational databases and in SDMX, they are inherently two-dimensional. So if you try to represent a multi-dimensional data set as a two-dimensional structure, you have a problem. So SDMX implements an approach implicitly that was developed in the 1990s, which is called a star schema, and which is used to deal with multi-dimensional data sets. So what you have is something like this. So you have a single, in the star scheme, you have a single fact table, which is referenced by a number of descriptor tables. Descriptor tables in the context of SDMX, that would be like our concept scheme and code lists, right? So this way you convert dimensions in a hypercube, in a multidimensional cube, into essentially columns of your data structure. So now, how can you deal with complex dimensionality? One approach is you create horizontally complex structures with many columns, and you add columns to them. That's one approach. And if you have ever developed an information system, especially a statistical information system, you know that adding a column to a database table is a big deal. It's a change that needs to propagate to all the upper tiers of your information system, where it's very expensive. In SDMX, we'll see it's even more expensive. So usually, that's why horizontally complex structures have been generally avoided. How else can you deal with this? You can create vertically complex structures. In this case, you keep your dimensions, your number of columns, relatively small, manageable, and you create complex mixed concepts. You create concepts or descriptors that implement more than one breakdown at a time. And so you keep the number of columns fixed, you add basically codes. You grow your code list, you grow your descriptor columns, descriptor tables. It addresses the immediate problem because adding rows to descriptor tables is much cheaper than adding columns to the fact table. But as we'll see, it brings its own set of problems. So adding columns, that means that we're working with basically, we're adding horizontal complexity using few columns, but long mixed code lists. That would be the vertical complexity. The third approach, again, whether it's a relational database or SDMX, is many pure structures and tables. So you're adding fact tables. And this is how you are supposed to work with relational databases by implementing the third normal form. But why have people not used the third normal form and instead use the star schema? It's because, again, multiple fact tables are expensive. And multiple data structures are expensive. So, long story short, you have a highly complex multidimensional data set. You try to implement this using a two-dimensional structure, be it a relational database or SDMX, you're going to have issues. So let's see what we have, what kind of issues we have and how we have dealt with them. So what is a horizontal complexity? A very granular decomposition of the observation key or identifier into many dimensions. This is taken from the Guidelines for the Design of Data Structure Definitions, which is a highly recommended document. So Horizontal complexity, it relates it to the pure data modeling approach, where you create many concepts, and the concepts are pure in the sense that each of them implement a single particular breakdown. As in this case, you can see, which is, I think, from the European Census Hub, sex, age, marital status, fertility status, and so on, and so on, and so on, and so on. So you create a structure with many columns. So what are the advantages? You got shorter and cleaner and much more interoperable code lists. Great. Such a structure is easier to map. And it's easier to constrain, and it's easier to analyze. Much easier to work with clean structures. However, it does result into a pretty sparse data cube. What's a sparse data cube? Well, you're creating this two-dimensional structure with many columns. For most of the rows, all columns do not apply. Only a few of them do apply. So that's a sparse data cube, and that's more difficult to work with in terms of visualization, in terms of processing. But even more pertinent, if you want to add a breakdown, and you do this by adding a dimension to a data structure, that is expensive. Again, and these are changes that propagate to all of your reporters. So let's see at the costs of horizontal complexity. The sparseness of data cube has been around and has been known for a very long time. It does have several implications. The one that is getting less and less relevant is the cost of storage. It was a big deal like a few decades back. Now it doesn't really apply. But structures with so many dimensions, they are difficult to map, more difficult to map. They are more difficult to work with. I mean, your code is more complex. In the case of SDMX reporting, the cost of adding dimensions to a data structure is huge. It's huge because not only do you incur those costs as maintainer of the data structure, all of your reporters must update their own mappings every time you add a dimension. The minute you add a dimension, that's a breaking change, that's a major change. All of your reporters must make the change, and probably all of your users as well. And that must happen regardless of whether you are actually going to use those new dimensions or not. The minute the data structure definition adds a dimension, your data flows, your mapping sets, your mappings are no longer compatible with the new version of the data structure. So how do you deal with this? You convert, I mean, what the answer has been most of the time to convert horizontal complexity into vertical complexity by utilizing mixed concepts. And again, we have an example. Well, actually, this is an older version of the presentation, but it's okay. This is an example from the ECOFIN DSD. You can see that this is a code that basically rolls 4 dimensions into one. Balance of payments, capital account, credit, US dollars. In the case of the SDGs, the SDG data structure definition is even more complex. It has 3 of such dimensions. So what do you gain? Is you gain the flexibility of lowering the cost of adding new dimensions. Because instead of implementing a dimension as instead of implementing a new breakdown as a dimension in your data structure, instead you add codes to your code lists. Adding codes to a code list is much less expensive. However, this vertical complexity comes with their own highly undesirable side effects, some of which are sort of to be expected and obvious, and some of them are less subtle, are more subtle, and are not realized at first. So if you have a true mixed code list, such as in the IMF's ECOFIN DSD, which collapses all dimensions into one, then for every indicator, you need a Cartesian product of all the breakdowns that it implements. So as we saw yesterday in the ECOFIN DSD, that's you have over 100,000 codes. You can take a different approach, such as the one that was done in the SDG data structure definitions and others, which is you implement a single code list with multiple breakdowns in them, right? So each code is still a code, but you will have, like in the case of the SDG DSD, we have breakdowns like type of international or name of international organization, type of natural hazard, name of non-communicable disease, all in the same code list, right? So again, what do you gain? You avoid adding these breakdowns as dimensions, which you end up with a very long and dirty code list. Again, some of the things you realize is that you can, some of the downsides is you have a potential collision, because if you have such a composite breakdown, you cannot use more than one breakdown at a time from the list. Or you need a Cartesian join. That's the other possible approach. It's very difficult to use standardized codes or persistent identifiers. Remember the FAIR principles? Try implementing them when you have 5 or 6 dimensions in a single code. That's, I think, probably either very difficult or maybe even impossible. Such dimensions, mixed dimensions, are difficult to work with, difficult to visualize, difficult to even assign a label to it, because you don't know how that, because there is no name for a column, because it implements many breakdowns, each of them has its own name. You cannot transpose, you cannot pivot on merged dimensions. And also, importantly, I've really been it's really been depressing to hear how, oh, well, yes, you created a reporting DSD, but now actually you need DSDs for dissemination. So you've put so much effort, you've created this extensive reporting data structures that has become a standard in itself, whether you want it or not. But now you're saying that, yeah, this is good, but this is only good for reporting. But for dissemination, you need different structures with their own concepts, by the way, their own probably codes, because you will be splitting the codes that you merged. What does it do for interoperability? And what I argued is that in the case of country reporting for sustainable development goals indicators, and when you say that the SDG DSD is optimized for reporting and not for dissemination, which is true, that is true. But the countries, after they've done all this effort, huge mapping effort of mapping their data to that humongous data structure definition, they've done that, and now you tell them, sorry, no, you can't really use it for dissemination. That's depressing. If I was in the country's shoes, I'd be pissed off. But there is something which is even more, which is maybe wasn't obvious at first, but has become one of the most important factors. The thing is that, again, if you read the relational, manuals for or textbooks on how to work with relational databases, you really need to have complete information in order to design your data structure definition. You need to analyze the properties of your data. That's right. So, and if you are developing a reporting structure, this is even more pertinent, because the costs of modifying your reporting structure, are, as we discussed, are humongous, huge. So then what happens is that you want to have a complete information on your requirements, data exchange requirements, before you release your data structure definition. As a result, the SDG data structure definition took 2.5 years to pilot and publish. The national accounts DSD was faster, but if my memory is correct, it was also like between 1 and 1.5 years. Every single global data structure took at least 1 year, but more likely many more years to develop and publish. Why? It's because you are trying to collect as much information as possible, because the cost of making a mistake is very high. The cost of not identifying a concept that needs to become a dimension is huge. But even if you spend 2 or 2.5 years on analyzing the requirements, you rarely get the full information. Even then, because it's difficult to obtain the requirements of data exchange on a global scale from 193 countries, for example. And so this is what happens. You are locked into a waterfall style design approach. You sit, you develop your specification, you sit on that for 2.5 years, and then you release it, and it's still imperfect and it's still difficult to use because you could not have, because there will always be requirements that you did not anticipate. So, and because of the cost of modifying your data structure is so high, you cannot start small and grow large. You must have the whole thing released at once. Okay, I think I need to hurry up because I spent too much time on the problem. So let's talk about the solution. So what do we do in SDMX 3.1? SDMX 3.1 addresses the issues with horizontal complexity. It makes horizontal complexity not as complex as it's always been. And it does it by lowering the cost of adding dimensions. The overall idea is that you create a data structure, you create your reporting or dissemination data flows, and then your data flows are not affected if the parent data structure adds dimensions. So how is it implemented in practice? We have a new type of content constraint, which is called dimension constraint. A dimension constraint can be used to define a subcube on a data structure definition. So such a constraint tells you, this is my data flow, and these are the dimensions that it uses, and you only list those dimensions that the data flow uses. So you have a subcube. Now, some might say that you used to be able to do that in previous versions of SDMX, and the answer is no. In the previous version of SDMX, for each data flow, you had to specify which dimensions it did not use by, for example, using the special value, typically _z, in a content constraint for that data flow. The point is that you always need to specify all dimensions, and you need to specify which ones you are not using. Instead, here, you can only specify which dimensions you are using. And then, if you get more dimensions in the DSD, you are not affected. Your structures remain valid. The data structure now can be defined by a data flow. Again, in all versions of SDMX through 3.0, it was the DSD that defined the data set structure. So if the DSD says you have 16 dimensions, then your data set must have 16 dimensions, even if it references a data flow on that DSD. But in 3.1, a data set only needs to use those dimensions that are defined for the data flow. And it remains valid when the parent DSD adds dimensions. Default values are a crucial new feature. If a data flow does not use all dimensions defined for the DSD, then when a hypercube is constructed based on all dimensions of the DSD, default values will be used in unreported dimensions for the data flow. And the final change is that the direction of, this is not directly kind of related to the horizontal complexity, but the direction of reference between the content constraint and the data flow has been reversed. In versions of SDMX through 3.0, actually, it was the content constraint that referenced the data flow. Now it's the other way around. It's the data flow that references the content constraint. So that creates a tight coupling between the data flow and constraint. And this is how it looks. So you have an example of a data structure definition on a population with a total of 1, 2, 3, 4, 5, 6 dimensions, including time. Frequency, reference area, sex, age, and I think it's current activity status. You use a dimension constraint to define a subcube on the DSD. And that subcube has 4 dimensions. Basically, what you have here is population by sex and age. And your data sets, as you can see here, only include these 4 dimensions defined for the data flow, plus time. And then you have another subcube, another reporting data flow on the other side, that only defines one breakdown, current activity status, right? So you have 3 dimensions in total: frequency, reference area, current activity status, plus time. So then that data set will not use sex and age, but will only use activity, because that's what applies to it. So now what happens is, if you look at these 2 data flows, df sex age and df cas, they remain unaffected if you add dimensions to the parent data structure definition. You can continue to use them for reporting or dissemination as you always have, even when the DSD adds dimensions. However, what you also get is you can construct a hypercube based on the full data structure definition. That is, you can bring all these data flows and their data sets into a single hypercube, a single data set. In that data set, you use _z for unreported values. So, what are the practical implications? There will be a lot reduced need. It probably will not be eliminated, but the need for mixed concepts like composite breakdown, custom breakdown, and complex indicators or series that encompass multiple dimensions, it will be greatly reduced. Not probably eliminated, but really greatly reduced. Pure concepts can be used. You don't no longer, I don't think you will ever you will ever need dissemination DSD anymore. Reporting DSDs will be using pure concepts, and dissemination DSDs, there is no need to create dissemination DSDs because your reporting data structures will be just as good for dissemination as they are for reporting. Interoperability greatly improved. Much faster development cycle. You can start with the requirements that you already know, and then you can grow your data structures. The cost of growing your data structures, the cost of expanding your data exchange are much lower than in current releases of the data structure definition. So you might think of it that in terms of like SDMX 3.0, it facilitated vertical growth of data structures by making it much easier to extend code lists thanks to code list inheritance. And 3.1 facilitates horizontal growth of data structures, makes it much easier to add dimensions. I think I'm done here. I hope I'm not too far over the limit.
Actually, no. Thanks a lot, Abdullah. We actually have 6 minutes for some questions, and then we can take more questions at the end. So if anyone from the room, yes. There is actually no poll because I think there are more questions from the audience for you than the other way around. Yes, in the front. Do we have a mic?
Yes, Danny.
Okay, thank you, Abdullah. It's very complicated, and it reminds me actually between what to choose actually between relational database or a document management database. What I mean by document management database, like MongoDB, where you can list all your objects and it's easy to maintain, faster to search, get the results, and so on. So my question is it something similar to document management database where we can manage concept or dimension at a level of objects? It's easy to maintain, easy to... so this is my question now that the cost of hosting the data inside the document management database is less, expensive than how it was before, and like we're moving away from normalization to the document management. Just
okay.
Yeah, thank you.
Thanks, Danny. Thanks for the question. I kept referencing relational databases, but actually here we're more talking about data exchange and dissemination, not about the databases per se. However, if we're talking about developing your, for example, production systems, or in some cases dissemination systems when you are not dealing with an SDMX native platform, then yes, then you would struggle with regular relational databases, and you might want to use something like a NoSQL database like MongoDB or something like that. However, okay, I have to say that I have not done that myself, but I have serious doubts about the how well NoSQL database will work for statistics. Because the huge advantage of relational databases is things like validation and referential integrity, which are a lot more difficult to achieve in NoSQL databases. I think that SDMX 3.1, when it is released, is a very strong incentive to move into SDMX native data management and processing and dissemination, because it will address these issues. In a platform like, by then probably the data lifecycle manager will have been upgraded, but basically you will be able to put all those multi-dimensional data sets into a same database without worrying about creating the data structures, without worrying about managing referential integrity. It will all have been provided automatically. So what I think that there is a good chance of this playing out is, instead of using NoSQL databases like MongoDB, people will start using SDMX native databases and platforms. And hopefully by doing that, they will get the best of the relational database world, integrity and validation, coupled with the ease of management multidimensional data sets. But just another quick comment. When you say that this is very complex, the idea was to take something which is very complex and make it simple. And I hope that this is where this goes.
Yes, thank you, Abdullah. It's very useful functionality. So for the time being, in our tools, we have something similar, but it's managed by annotations. So we can create a big, let's say, data DSD, then we create a cube, and when you create a data flow, we can fix a value, and then we can hide a dimension just for visualization. But all the data, they came from the same table. My question here, if we will manage with the dimension constraints physically, I want to go a step ahead, data will be managed in the same, or each data flow will be managed in the separated databases or tables. Because for the time being, even you hide, the system doesn't allow you to load empty values. So you should, but if I understand well, you mentioned default value.
Well, this is a question that probably is better addressed at Stratos or Nadia, because they are the ones who develop the tools. My guess is that these tools like reference infrastructure or .stat, they create, not reference infrastructure, like .stat, for example, and eStat toolkit. They create a table per data flow. I would think that most likely it's going to remain the case. But the difference is that then the multiple data flows on the same DSD can have different structures, but then you can also construct a single hypercube from all these multiple data flows. So that's what is going to change. It's a design choice. You could also create a single table for the data structure definition. That table would be basically reprocessed, would be recreated each time you add dimensions to your DSD. That's another design choice. So you could keep all the data flows in the same table or multiple tables. It's a design choice.
Sorry, so I think for the sake of time, we can take more questions at the end. It's fine. Because I have plenty of time at the very end, half an hour for more questions. And now we can move on to the next presentation. Thanks a lot, Abdullah.
Okay, thank you.
And the next presentation is by Matt, who explicitly asked me not to introduce him again. But then at least I would like to thank you for helping me organizing this session. And Matt will talk about SDMX 3.2 and custom structure definitions.
Okay, thank you, Bianca. Yeah, I think everybody knows from yesterday who I am. So I think I have 15 minutes to talk about this A new feature pending for SDMX 3.2, which is coming the end of 2025. So the status is we have a problem presented to the TWG. We create some concept designs of how we can solve that problem, and then the design is approved, and then we forward the design. So at the stage of the concept has been approved, and we've still got some things to flesh out. So it's not a fully finished feature. We're going to be working on that next year. But the problem came in as presentational metadata. So it's okay, how do we have metadata in SDMX that describes how we want to present our data, maybe in a pivot table or a pie chart or a bar chart or many other things. And it's quite a complicated problem because, I mean, I remember doing work for one of the central banks, and they were saying that the most kind of emails they would get about the way they were disseminating their data was all on the charting. Why don't you do this? Why don't you do this? Why hasn't it got this thing here and that thing there? So in the end, they just got rid of all their charts and all the emails disappeared. And people weren't that worried about it. They could still get the data through tables. So the point is really hard to, I think it's really hard to standardize on all the various ways in which you can present data. And then the question becomes, who's the audience of this metadata? Is it the world, or is it your own dissemination system? Because if it's your own dissemination system, we don't need to create a global standard on how to present the information for your system. What might be better is a way for you to still work with a metadata-driven system, so you can still have your dissemination tier fully metadata-driven, but without SDMX being so prescriptive as to, if you want a table, it has to have these properties, and a chart has to have these properties. So to give the flexibility to be metadata-driven, but without imposing it on everybody. And this is where the custom structure definitions come in. So the idea, the general concept is, as we know, SDMX has an information model. It's a very, very powerful model. It has a lot of inheritance in the model. So here's an example of the model. We have two artifacts, data structure definition and data flow. They inherit from something called maintainable, which inherits from nameable, which inherits from identifiable. So at the higher level inheritance tree, we introduce properties like nameable, well, it has a name, description, multilingual. Identifiable, it has a mandatory ID, and maintainable, it's owned by an agency and it has a version. So these are the properties that both data flow and data structure definition inherit. And in fact, every maintainable, every artifact will inherit these properties at the high level. And then the structures then have properties specific for the structure. So a data structure definition has dimensions, attributes, and measures. A data flow has a reference. Well, actually, in 3.1, it has a reference to an optional reference to a data constraint, and optional reference to a dimension constraint. So what if we could design a new artifact for our own use case, which extends maintainable? So for example, if I want to design in my system something called pivot table, I would say I have an artifact, it's called pivot table, extends maintainable, and it has these properties. It has a reference to a data flow, it has rows, columns, and slices. And actually, this is quite nice because what it allows us to do is it allows us to not only kind of add properties specific to the object we're designing, but we can start to make use of other SDMX artifacts. So, and we can verify and validate and ensure referential integrity within systems like the FMR. So, for example, if I design a pivot table and I say it has a mandatory reference to data flow, when somebody actually submits an instance of the pivot table, we can verify the data flow exists, and we can create that link. And therefore, we can prevent users from deleting the data flow because it's being used by the pivot table, for example. And the same thing with things like the references to the dimensions. We can actually do verification and validation and create these links. And this is very powerful. And I'll talk about why in a minute. But before I get to the why, So what I've talked about before was kind of designing what a pivot table is. That's the custom structure that you have defined. So you're defining a new class of structure. You've called it pivot table, you've given it properties. After you do that, then people can then report instances. The same way that you would report, same way you would submit a code list to a system, because SDMX in the information model says a code list has codes. You would submit a pivot table into the system. It's just that the SDMX information model doesn't contain that. You've extended the model to define a new class of structure. So really the instance is going to be based on the way you've designed it. So here, for example, my pivot table has the agency ID and version because it requires this because it's a maintainable artifact. It has a name, which is also required because it's maintainable. And then it has the properties specific to pivot table, which is row, column, slice. And it references a data flow, and the data flow references a data structure definition. So it comes with benefits, because what this allows us to do is we can have a fully metadata-driven system, and the metadata can be stored and maintained in the same structure repository as all of the other structural metadata, which allows us to reuse other artifacts in that repository. By referencing the other artifacts, we can start to make reuse of the information model, and therefore we get the validation, because the FMR or the registry for processing the submission of the instance, the pivot table instance, can actually verify it has the correct properties and verify the other artifacts exist. And that gives us referential integrity, because now we can't do things like delete the artifact because it's being used by the pivot table. So we have the integrity insurance. And we have things like the semantic versioning, of course, so we can actually semantically reference artifacts and therefore late bind to like the latest data flow or the latest DSD. And the artifacts that we submit to our registry has a URN and therefore can be referenced by other artifacts. So I could, for example, create reference metadata and attach that to my pivot table, because I might have a lot of information about this particular table, and it becomes a referenceable artifact. So I could categorize my table through the SDMX category scheme. So you can actually start to reference the artifacts the same way that you can reference any other artifact in SDMX. And you could also share your artifact. So actually, if you create a nice definition of a visualization thing, maybe a line chart or a pie chart that another agency wants, you can share the custom structure definition, and then they can create their own instances for their own requirements. And discoverable. So for discoverability, there's two parts to this. So there's the custom structure definition, so the actual definition of the object class. So we'll just reuse the REST API for this, the same way that you would query for a code list or a concept scheme or a data structure. The REST API says, what structure type are you after? In this case, it's a custom structure. Who's the agency, OECD? What's the ID of the custom structure? It's pivot table version 1. You get back the metadata that describes what the pivot table definition is. Maybe there's a version 1.1 where there's a new attribute placement, and maybe there's some kind of new version with some other properties on how time is formatted, for example. But the instance can also be pulled back through the REST API, because the instance is just like an instance of a code list or a data flow. So the same way that you would query for a code list or a data flow, you would query for the actual pivot table. So I want the pivot table from the OECD, population, sex and age, star, so late all versions. And then I get the pivot table back. Or maybe I want to use detail stubs. So this is like, it has the full kind of REST API capabilities, so I can get all the pivot table definitions. Or I could actually say I have a data flow called population, give me all the things that reference that data flow, and then you'd get the pivot table definitions back. So you could build a user interface for your data, and then allow people to pick how they want that displayed. And that can be fully metadata driven through the REST API. But like I said at the beginning, visualization metadata is really just one use case. We could do more. Well, this supports more, right? So you could say, well, we're going to create a pivot table for visualization metadata, but actually we have other parts of our process where we would benefit from custom metadata. For example, in FMR, there's a few extensions to SDMX. There's actually two object types in FMR which are not part of the SDMX standard. One of them is for data collection. It's called the reporting template. It's a really nice capability which generates an Excel form for people to fill in for data collection. And another one is publication tables for dissemination. But you could imagine these would have been actually modeled using the custom structure definition. So we want to create a reporting template. It's a type of maintainable artifact. That's the output of a reporting template. That's the thing that's generated by the system by obtaining the metadata from the system and generating the template. And there'd be a model behind it. Now, this is like a one-time operation, because you're not going to be constantly creating custom structures all over the place. So while this may look a little bit complex, this is like you're designing a new structure type, you do it once, you save it, you're done. So what we see here is we design a reporting template. We say it's got a property called an instruction sheet. It has one or more reporting worksheets, so Excel worksheets. Each worksheet must reference a data flow. And it has rows, columns, slices, variables, attributes, and they're all references to dimensions or attributes in the data structure definition. And we can reference a hierarchy, an SDMX hierarchy for presenting the codes in the template as a hierarchy. So that's kind of how it would look if it was done via the custom structure definition. And I believe that's it.
Thank you, Matt. So while we do have some time for questions, I will also put up again the Slido, so in the meanwhile people can answer. But please stay, Matt, because you can take the questions. Is the mic? Yes, please.
Okay. Just for me to understand exactly the scope of these custom structures, yesterday we talked about a potential representation of the matrices in the matrix generator or in the future interface of FMR. Would it be possible, for example, to overlay on the top of a category scheme a custom structure that then is used for matrix representation, or am I not getting the scope right?
I'm not sure. I mean, from what Glenn was presenting yesterday, where he showed this kind of extension in the FMR, yeah, that is a primary candidate for the custom structure definition, yes, because it's something new which contains information which is actually referencing other parts of the model. So, yes, if I've understood correctly your question. Yeah.
Thanks. Thanks, Matt. Really interesting presentation. And so if I get it correctly, it's a kind of standard way of adding, let's say, local standard extensions.
Yes.
And of course, it's very nice, very flexible. You showed good examples, also the reporting templates. But I have the impression that it would be also, there is a cost to it. And the cost would be, you kind of add two types of citizens in the SDMX model. You have the first-class citizens that are part of the standard, and everybody knows about them.
Yeah.
And then you have this type of second-class citizen.
Yeah.
And thinking, for example, about libraries like PySDMX, but it would be the same for SDMX core. It's all pretty much domain-driven, so we define classes like we have a code, we know it must have an ID, it must have a name. It may have a description. I mean, all this is fairly well defined. We can code all this. In this case, that would be more complicated because it's not that you need to change, for example, your classes whenever you have a new version of the standard. But in this case, it may change any time when the metadata changes, and it starts reminding a bit more about introspection in Java, for example. So it's just, I'm not saying it's necessarily bad, but it's not cost-free. That's what I'm saying, especially for libraries.
Yeah. So, yeah, I mean, the way that I'd answer that is, at its core, SDMX is actually quite simple in the structures that are required to do things, right? You have the code lists, the concepts, the data structure list, and the data flow. And then requirements come in for other things, right? So we need this, we need that, we need the other. It starts getting wider and wider and wider. And all the tools then need to implement and support all of these features, even if the features aren't required by people. So then you start to kind of move down the path of, say, visualization. And the question becomes, well, who is this for? Is this just for your website? And if the answer is yes, it's just to have a metadata-driven website, then really the other tools don't need to know about these custom structures because they were never really intended for everybody in the first place. They were just intended to allow the agency to be kind of metadata-driven, but stay within the kind of SDMX information model. That would be my answer. And if we find that actually some custom structures become very, very widely adopted because everyone says this is a really amazing capability, you could then foresee that maybe becoming part of the information model to say, well, actually, this is something that is really required within SDMX. But it was just a way to prevent the standard kind of going too wide. Daniel. Oh, sorry, I just saw you waving at the back.
Sorry, it wasn't on.
Okay.
So yeah, I mean, it seems really interesting. In terms of for interoperability, I mean, apart from all of the advantages that you showed, you could see that if something becomes really interesting for like standardization, so and at a level of like a cross-domain thing, or a cross-agency usage, then perhaps this could be looked at by the SWG as well, right? I mean, a prime candidate is the annotations. So the custom annotations, we did a lot of work on those, and they've been implemented, but you have to know that there's this PDF, right? And you have to know that the tables are there and they work like this. And mistakes can be easily made with implementing those annotations. But I'm sure that using this kind of artifact, then or this model, we can actually put some more kind of like control or some quality assurance around it. So yeah, thanks.
Yeah, precisely. Yeah, it's to move away from the weakness of the annotation without SDMX being so prescriptive that everybody had to implement something. And if you find that the OECD produces some custom artifacts that are actually very widely adopted, then you can imagine the tools would start to kind of implement the support for these capabilities.
We can take one last question.
Yes. So good morning, and thank you again for your presentation. And I have something similar to what I said to Abdullah, because in ODP 2.0, we are managing this kind of, let's say, layout of presentation using annotations. So my suggestion here, first, maybe, and I will join what David said, to check about annotation guidelines to harmonize taxonomy, for example, or terminologies. We used to use the word filter, then slice. And I have a question, I don't know if you have the time, is in addition to row and columns, it seems that you can specify some additional attributes, something like that, like unit or I don't know. Just to know what is the purpose in addition to presentation layout, what we can do with kind of this custom. Thank you.
Yeah, okay. Thanks for the question. Yeah, so my examples were just examples which I made up. The custom structure definition allows you to define whatever properties you choose with whatever labels you choose to use. So therefore, you could design any type of artifact for whatever purpose you want. Say, for example, you want to define an artifact which helps with a data collection process pipeline. Then you may create an artifact, and then you give it particular properties, and those properties have a data type. So you say this is a numerical property, this is a string, this type of property is actually a reference to a data flow. So those were just examples. The custom structure definition doesn't prescribe anything. It just says it's an object which allows you to define properties, give them a data type, and then people can then report instances of that.
So thanks a lot, Matt.
Okay.
Thank you. We can give one last round of applause. And I'm also happy to announce a coffee break now, so we will start again at 10:45. Thank you.
Last evening, did you join the dinner? The dinner. It was so many people, but so many people and so many rooms. Yeah, that's true. But it was a nice building. Initially, we arrived early and we were sent up in the first floor. And they said, "Oh no, you're not this group. You have to go down again." No, it was well. Maybe in the end we have to go. Yes, so. You never know. So let's see. We came in a restaurant that had a different menu, so it was like. Okay, let's see. Okay, duplicate, no? Duplicate. Take some time to wake up, or do they have to do something? I guess so. I guess they have to do something. They have to. Yeah. But that should be enough. Yeah, I think it should be fine. And duplicate. If one can see that, it's not good. Yeah, but the only thing I have is this and the. Whoa, interesting. Let's see. Did I lose the? That's the problem. Okay. Yeah, the Wi-Fi is not so trustworthy. I don't know if I need to connect to my phone, maybe. No. Okay. You can test one for instance, and it is taking a lot of. I know. Should I try the default? Is it running like this? Yeah. Perfect. So, just one final thing because I'm getting older and I'm forgetting. So, where should I stop? Should I go? You said, but we can do it otherwise. What you said, if I remember correctly, is up to there, I think so. But if
if you want to do this, and then I can take it, but my idea would be to...
Okay, so you do
this,
the
the
demo.
URL resolution, I want to explain it with the example, so I mean, showing the URL.
Is it all working good here?
Yes.
Okay. So I just wanted to ask you, is Antonio Olleros, right?
Olleros, yes,
But you can call me whatever.
nobody will know Olleros. Everyone knows Oleros.
I was told that in Greek means the old man, you know?
Really?
Olleros.
Ah, Olleros. It's the article of Hieros.
Does it have a meaning in Spanish?
Sorry?
In Spanish, does it have a meaning?
Potter.
Like Harry Potter.
Is the
Like Harry Potter,
well,
yeah.
The pot,
Ah,
yes,
okay,
the
yeah.
pot. So, or pot maker, I don't know exactly. I was telling the son of a friend once, because I had never thought about it, but my surname is Potter, I'm the cousin of Harry. He was amazed, he couldn't believe this.
Okay, so should I? Yeah.
Yes, so that's it. But if you want, because I was thinking of doing first this part so we can already with the solution. Because I think it's easier because we see a URL, right? We see everything, and then I think it is easier.
Okay. So should we move it then? You think?
If you want, we can move it below the other one, exactly. And then I can store with the message.
Maybe at the end, or what do you think?
It's fine because
just,
my
yeah,
idea
just
is that
before
this
the-
form I would just say, okay, this is for reference, and I'm going
Perfect. So I'm starting with the example, and then you go on with the demo. Perfect.
Good, thank you.
Thank you.
I think we have after that. In the program is before.
Ah, could be. I thought it were. Okay. So. Yeah. Good.
So, welcome back, everyone. I hope you had a good coffee break. We will now go into the second part of this session. We will have two presentations, one on the SDMX REST API, and then the Global Discovery Services Part 2. And after this, we will move into the poll results. So, SDMX REST API, Xavier is going to present. I think he doesn't need to be introduced again. You should already know him. Over to you.
Thanks a lot. Thanks a lot, Bianca. Yes, so it's again a pleasure to report about the status of what we do in Task Force 4 of the SDMX Technical Working Group. And so the Task Force 4 is a subgroup in the Technical Working Group. And I usually present and make a status report, but actually it's a whole team behind it. And actually I think all of us are in the room, if I'm not mistaken. So Attilio, Jens, Matt, Nadia Stratos, and myself. And I've seen the previous days, I don't see him now, but we have also colleagues that used to work with us and now have left, like Olaf from CBS. So it's really a team effort. And then, of course, we have also usual suspects in the technical working group or statistical working group, making sure we have enough work. So sending interesting feedback, and also from the community. So it's really a team effort. So what we do, we maintain the API, and for most of the people that means REST. But a while ago, we had also the SOAP API. It was kind of in maintenance mode, but then it was officially deprecated in 3.0. And I think none of us were sad when it reached the end of life. And how we work, everything is visible on GitHub. So as I'm sure you are familiar with, the TWG has a space on GitHub in which we have many repositories, and the repository for the REST API is one of them. And we have everything there. We have, of course, the specification, the documentation, but we have also discussions that can take place. We have the issue list, so everything is fully transparent. So if you want to reach us, I guess that would be the way. And so historically, what we started with was the SDMX REST API that we call version 1. Of course, we use semantic versioning to version the API, but there are basically two versions that counts because it's two major versions, version 1 and version 2. And they are not compatible with each other. That's the major increment. And when we started with version 1.0.0 in 2011, the idea was to make it very simple because SOAP was too complex. We had a presentation at a global conference where you had a slide, and it was a simple query, and I think it fit on 3 slides. And then we had the equivalent in REST, and it was a one-liner. So the idea was really to make it very simple. And we had 8 releases between 2011 and 2020, and they were all backward compatible. And we supported the usual suspect, right? First of all, before you can retrieve data, you need to discover what we have. And so data discovery was supported right from the start. And this is where you can use things like structured queries and a type of query that was introduced a bit later, the availability queries. And they really support developing applications where you could ask questions like, what data flows do you have in the sources? What are the providers? Give me additional information about this data flow, and what are the valid combinations for the dimensions. So all these things were supported. And then, of course, once you know what you want, then you can retrieve it. And this is the purpose of the data queries. That was, of course, there as well. And then you could also do data validation via the schema queries. And basically, this is what we had in version 1 of the API. But then came version 2, published with SDMX 3.0, and unfortunately non-backward compatible. We tried hard to stay backward compatible as long as possible, but it was not possible in the end. There were just too many requests. And so once we got the license, to change pretty much everything we wanted, then we did it. So, because we had this opportunity, it was a one-off. But then it's non-backward compatible. There are many new features there. I think one that is very interesting is we try to make the data queries even more powerful than they used to be. So we have, so before you could, the data queries were limited per data flow. Starting with the version 2 of the API, you can go across data flows or even across data structures. You can select the context very granularly between data structure, data flows, or provision agreement. You can wildcard any of the ID, agency, or version, so you can really go across context, which was already, I think, quite good for data queries, but we didn't stop there. Before, for filtering, you needed to use the series key. It's still there if you want to, and the series key can be partial. So that's powerful as well. But we introduced also the possibility to filter by components. So you could say, give me any data across data flow where the reference area would be Switzerland, for example. So this is, of course, something very powerful. I'm not saying this is working against any implementation, but if you want, you can do it. Because, of course, it's a very expensive query. And then we introduced also operators, because typically, like I was saying now, we say, okay, well, the reference area is country XYZ, so we think about the equal sign. But we introduced also support for operators. So now you can use things like greater than, less than, contains, start with, end with. So you could actually perform queries like, give me time series where the title contains, I don't know, inflation. So this type of queries are possible. So we really worked hard to make data queries more powerful. Then, thanks to Stratos, so we have the maintenance operations now added, because before it was mainly about retrieving structures. So retrieving code lists, retrieving DSDs. Starting with version 2 of the API, you can also use them for maintenance. So you can make changes and post them back to the registry. So that was also a big improvement. And then thanks to Matt, we have better reference metadata queries. And because before, I think it's fair to say they were not really working in version 1 of the API. So they didn't get much attention, I'm afraid. But starting with version 2, I think it's a really nice API to search for reference metadata. You can search by a metadata report ID if you want to, but you can also search for any reference metadata attached to a particular structure, or you can find all the metadata, the reports that have been reported against a certain metadata flow. So I think we covered the full scope of what was ever requested in this context. Then, of course, we had a lot of the 3.0 features that we needed to add support for, like geospatial code list, semantic versioning, the array types, but also multiple measures, for example. So all these needed to be added. And then that might be the most painful point, but we had to go through this. Thanks to the very nice TCK done by Nadia and her team, we could test then various web services for compliance, and then we realized that even if we tried hard to make the spec as simple as possible, we still managed to understand it differently for some of the cases, so that was kind of a shock. But then we took all the points and we had to improve the documentation when it was not clear enough. So a lot of effort was spent on that as well. Still not perfect. We still get questions about what do you mean with this particular part, but I think it's better than it used to be. And then we have also released a minor update to it in January this year, version 2.1, where I think the only notable change is we have now support for registration queries, which was something that was possible in SOAP, but not in REST. And because SOAP had been deprecated, we try to be at least feature complete. Now, the next release, the one that will come with SDMX 3.1, I think it has a few interesting changes as well. probably a bit more ambitious than the previous release I was mentioning, 2.1. In 2.2, that we hope to release in the coming weeks, we have added support for something that was requested, which is support for time travel. Unfortunately, only for data and metadata, obviously, but that's a start. This is nice because maybe you have published a report, I don't know, in March last year, and you would like to know what were the state of the data as they were when you published that report. And so we have introduced this as-of parameter, which takes a timestamp, and if the service supports it, it should return the data as they were at that point in time. Now, this is the classical case, but this time travel is not limited to data, right? Because you might want the same for metadata. You might want to say, okay, that was the data for the reports, but what were the state of the structures at that point in time? There were discussions whether this overlaps with semantic versioning, but it does not really, because if you take, for example, a structure like a data flow, it references the data structure reference concept scheme, code list. They might all have a different semantic version associated with it. And you don't want to have to go through all dependencies and transitive dependencies, find their version, and then retrieve them individually. I mean, that would be the alternative. But in this case, the work is really pushed to the server, to the service, to say, okay, I want the metadata as they were at that point in time, and do your thing. Then another frequent request was about sorting and pagination, because we never really cared too much about it. We were saying, okay, if you want, you have a streaming response and you digest it as much as you can as a stream. But there were still use cases, for example, to drive user interface where you would like something like pagination. And so we added support for sorting and pagination. And in this case, it's really, I mean, all of us familiar with SQL will recognize it. Basically, there is a kind of sort by and then offset and limit, and they do what you would expect. Maybe the only thing worth mentioning is you can have multiple sorts, and there are also special keywords. Like you see one example here, it's saying series key. So this expects the data to be sorted by series key in ascending order, and then by time period in descending order. And then you can paginate using offset and limit. Support for segmented constraints / horizontal DSD, or I mean, that's, I guess, a summary for it. That's how to support horizontal DSDs, right? Via segmented constraints, I think. Dimension constraints, okay. So should be dimension constraints, sorry. And then there were also, again, further clarification and minor edits. You can see the full list of change on GitHub, and this is true for all versions that we publish. There is a tag associated with each version, and all the releases are available on GitHub, and each of the releases is associated to a milestone where you see all the issues we solved. So if you go there, you follow that link on the presentation, you will see everything we fixed. And so what would we like to do after? Because, and that must be the first time since 2011, once we have completed the work for 2.2.0, the list of issues will be empty for the first time. Now, this is not an invitation to go and start adding new issues. Huh? We are happy with that state, but there are still things we would be really interested in. One of them is to define API for business functions like validation, mapping, format conversion. At the moment, the API is primarily about retrieving data, metadata, okay, also some maintenance for metadata. But would it not be nice if we could also pass the data and then tell the service, please validate, or map, or do the format conversion? This is, of course, very useful. Many of us have it. The FMR has it, for example. It offers all these functions and more. But there was never any discussions about the API. So how to call the endpoint, what should be the parameters. So the idea there would be to ask the community the functions that they would like. Here we have the usual suspects, but for example, internally at the BIS, we have other functions that we use, like we have a summarize function that summarizes the content of a submission. We have another function that infers the context, so it takes a peek at the submission and tells us, for example, the data sets, provision agreements. So it would say the data flow, the data structures, the provision agreements, the actions, and this type of information. And I'm sure in your respective organizations, you have many similar functions. So the idea would be to highlight the ones we would like to expose via the API because they are useful enough. And then define the functions signature and what they should look like. And then there was another one, and that was triggered by an excellent presentation made by Pedro about in the technical working group, I think in DC, where he was explaining how they were experimenting with gRPC as an alternative to REST, possibly. And this is, of course, also very interesting. gRPC might not be, is not definitely as popular as REST, and there are reasons for this, but it serves certain use cases very well, probably even better than REST. Anything related to, for example, efficiency or performance is typically better with gRPC. So that could be another thing that if there is an interest in the community, and at least a few of us have expressed it, then we could start working on. Because like I was mentioning, TF4 is not only about REST, it's about any API. So before we had SOAP as well. And if there is an interest for gRPC, then we would go there. And I think that's it. So thank you very much.
Thank you, Xavier. We do have some minutes for questions, and I will come just to put back the QR code because the poll is also open for this presentation. And if you have questions from the audience, you can raise your hand. Can we have a...
Thank you, Xavier, for the presentation. I have a question regarding the time traveler, which looks like a very interesting feature. But did I understand well, it is supposed to provide the data previous to corrections? Or, I mean, the use case, the idea is what were these data that you had by that date, and now maybe they are updated and they are different? Is that the idea, exactly? So.
That's a very good question, and we have added documentation about this because, as you know, we have now different parameters that are related to time. In addition to this new as of, we have also updated after, and we have also with history, or include history. And and then there is also what HTTP itself offers, like if not modified, if modified since, or so. We have added examples and use cases of for the 4 parameters and their combination. And based on what you say, I'm wondering whether you would not be more interested into the include history so that you could see the previous value and then the revisions, unless I misunderstood. But we could go through the examples together if you want.
No, for me, I think it is very interesting, but I guess that's depending a lot on implementations, right? Because this concept of correction, which is very clear, very obvious, I don't know whether it is formalized in the SDMX model now, right? So I guess it is very highly dependent on implementation, but I think it's clearly very useful.
Yeah, in this concept, for example, let's say you would receive, I don't know, one observation that would be an estimate, and then you would receive a second estimate, and then you receive the third one that is final, and so you change the observation value and also the observation status to indicate that it's final. If you want to see all 3, there you would need to use this include history. This as of would say, okay, give me the value for this observation and its status as it was at the time we published, which could be the second estimate or the first estimate or the last one, but it would be the state at that particular point in time. Yeah, thank you.
There's another question here. Glenn?
Yes, on the offset and limit, does that work at the observation level or at the series level, or is it sort of dependent upon the context?
Good question. I would say, if I remember our conversations in Paris correctly, otherwise I would need to check the documentation, but it's context dependent, I think. Because it's totally valid to not ask for any observations. And so you say, okay, just give me the series and their attribute values, for example. So in that context, I would translate this as retrieve the first 100 series. Yeah. But Jens, Matt, if you have a different opinion. Yeah.
Good. See no more raised hands, so thanks, Javier. And we have now our last presentation of the session. After this, we will see the results of the poll, and then I will ask again all the presenters to come back, just to warn you. So last presentation, SGDS implementation. I think Stratos was already introduced, so I will briefly introduce Antonio Olleros, who is the founder and CEO of Meaningful Data. He's providing software and consulting for official statistics and regulatory reporting. He has over 12 years of experience in regulatory reporting at the Banco de España and at the ECB. He worked for the Single Data Dictionary and for BIRD at the ECB. Stratos and Antonio, please, floor is yours.
Perfect, thank you. And yes, as promised, this is SGDS Part 2, and hopefully we'll be a bit more detailed about the implementation of the API for the Global Discovery Service and give you some more insights. So, just keep this I keep this in the first slide for consistency, no need to repeat. Problem statement, we're hoping that we are, continuing on the same path and we're not deviating. And again, this is a bit of a technical details, no need to detail this. But what I would like to talk a bit is about the information model. And believe me, this is as simple as it could get. And it's not often easy to really design an information model that could cover all the use cases. So in our case, we had 3 main entities to model. So we have the agency, which is what we already know and we already appreciate in the SDMX information model. But then we have 2 different entities that were related to the agency. And first one was the endpoint, and by endpoint we mean the physical implementation of a web service, so be it a registry or maybe a data or structural repository, not necessarily a registry. And then the publishing location, which I think it's not the best name, but after all, we discussed that the shortcut pub location is quite interesting if you think that it reminds of a publication, but in this case is a location of a web service. So the pub location is actually where an agency would expose their metadata or their data. So that's the essential difference between the endpoint, which is, let's say, the physical endpoint, and the pub location, which is the logical place where you would find something from an agency. So you see this the information model here. We have the endpoint and the publication at the center. A bit of information around them. We'll see about this also in the API calls and the responses. And how would we connect this? This was, I think, the most straightforward way by the agency, right? By them being both related to a maintainable artifact, they both had an agency. And this would be the owner on one side for the endpoint, on the other side for the publications. And that's why this is represented by a scheme. We try to keep a bit the paradigm of the information model to make it a bit more, let's say, familiar to SDMX acquainted, let's say, audience. Of course, it's still an information model. It's not supposed to go to the end users so much. So so far we had an API which was deprecated, but of course it was only a beta version. You can still access it under the SDMX.io, but it will not be there for long because we have updated it. And I would directly go to the new API. Now, the idea of the new API is that we wanted to enhance a bit what you can get and what you can ask the GDS for, because before it was based mainly on the entities. But having discussed this with the TWG, we thought that we need to make it a bit more useful. And although the information is not that much at the moment, we wanted to answer meaningful questions like, where does agency XYZ, BIS, OECD, or SDMX as the, let's say, top level, the top agency of our community, publishes data or metadata? Or maybe who publishes data in a specific endpoint? Or maybe give me a location, like the first question of a service is for BIS or OECD, but filter them by resource type or by formats or by the API version. So all this information might be useful for the client. And in this case, most of the clients are other systems, right? It's not so much for the end user, but it's for client systems to discover what's out there. So this was the objective. And I think that the final question was the icing on the cake, as they say, which was to resolve the URL. Of course, it came from another path, let's say, to the GDS, and it could be even implemented completely outside the GDS. But we had the opportunity here. We had all the information we needed to resolve a URL. And this is why we put it, let's say, experimentally here, and we will see how it works. And the reference resolution pattern actually is for the API, so you will find similarities to how you can query the different entities, like, resolving children, parents, and so on. So this is a bit of a technical thing, and I don't think it's so important because it's relatively low complexity in terms of the relationship between the different artifacts. Now, the new API info page is not, it's public but not announced, and it will get really public under the SDMX.io soon.
Development mode.
Yeah, it's in the development mode, right? And this is the entry page. It's a typical Swagger UI page, so you can test it, and we will see more about this. It's just a first snapshot here. And here we have a few examples. Like, for example, where does the BIS publish data? You would ask this by giving the publication scheme of the BIS, and we try to keep, again, the identifier to a fixed, let's say, identifier, but those are all under revision, and because the idea is to further expose this to clients and let us know if they think that it's too complicated or it's too simplistic. We will have to see about this. And then the question is, okay, give me the publication scheme of the BIS, but only for data. So we have the resource equals data. Then we could ask something like who publishes data or metadata or anything on the global registry. So we would start from the endpoint, saying I have the endpoint, which is the global registry, just give me all the parents, which means who is using this endpoint in their publications. So this is the next use case. Then maybe a bit more complicated, like I need all OECD metadata, but only JSON formats and only for version 1.5.0. So I've tried to make this nice rainbow to relate the questions with the parts of the API. So you see that we ask for a publication scheme, we request explicitly metadata as a resource type, JSON as a format, and 1.5 as the API. I know the purple was not very well in this screen, but you will get the presentation anyway. And finally, the idea for the URL resolution would be like, where can I find an artifact that has this URL? Because the URL in SDMX is supposed to be unique across the community, but still it does not give you any hint of where you can find it. I mean, you could read it and say, okay, this is from SDMX, maybe I would go to the global registry. But since we have all this information in the GDS, now you can simply say, okay, resolve this URL for me. And with this, I give the floor to Antonio to
drive you through the details. Thank you very much. Well, one thing, there has been a slight change in the order of the slides. So maybe if you are following the presentation, you are going to see that this is the second after this one. So I just wanted to show you the cases we have, okay, with the actual application. As Stratos said, it's deployed, but it is in development. We just deployed it so that we can exchange easily information with him, right? So it is not supposed to be something that it is final or something that has to be used. But I'm going to use this to illustrate the messages. So in the next slides, you are going to see the kind of new messages that we have, okay? But I'm going to show them with the application because I think it is nicer to see. So as Stratos said, we have a deprecated implementation, right, with some endpoints and some responses that we are changing. And now in the new API, we have the new kind of responses that the idea was to align them better to the existing REST APIs. Okay, because now the first implementation was a proof of concept, basically, so it was following a very, very light specification. Okay, so now we are really following the kind of queries that the SDMX REST API standard use and the kind of messages. Very importantly, if you have used the previous API, you will have realized that we were nesting a lot of information, right? So if you were requesting information on an agency, you were getting its path locations, and then you were seeing inside the endpoints and so on, which is not the usual way that the SDMX API works, okay? So now everything is flattened, and everything is following the SDMX structure. So let me show these cases. Okay, here we have the new front end for the API. We have first an endpoint for a SDMX API. This, I mean, is basically just telling you that there is the version 1.5, 2.0, everything. I don't think this is going to be widely used, to be honest, but this is one of the objects we are managing, so that's why we wanted to have them. Then we have the agencies, but here I would like to warn you. I mean, the idea is not to substitute the agency scheme, an agency that we already have in the SDMX APIs, right? Here the query is more, for which agencies do we have information in the GDS, okay? This is the kind of information you are going to be able to find here. So we are supporting the asterisk. I hope you are able to see it. Like the SDMX standard API, and if I execute it, so I see that at the moment, these are the agencies for which we have information in the GDS. I insist, this is what this is telling us, right? Not that there are no other agencies with SDMX or something like that. This is the simple one, and now we go to the interesting ones. We have the path location scheme, okay? This is the entry point, as Stratos showed. Now I wanted to show you a couple of use cases, okay? So you may recognize here the pattern that we use in the REST API, in the standard REST API, right? Where we see this is what we are querying, then you have the agency ID, the resource ID, and the version. And then we have additional queries. So we are also able to select more than one. For instance, if I want to see where the path locations are in the BIS and OECD, I can separate it by commas, I can select the asterisk or whatever, like in the standard API. The resource ID, to be honest, in the case of the path location scheme, I expect, many times I expect things that don't happen, right? But I expect that each organization is going to have one, and the ID is not going to be familiar. So I would expect that mostly everyone is going to use an asterisk here, okay? And for the version, we are supporting also the asterisk and also this character, I don't know, sorry? Tilde, okay. That is also supported in the standard API to say that we want to see the latest, okay? So here, right, the kind of question we want to do is where can I find everything or metadata or data? Let's suppose now that I want to see the data. So basically, we want to know where BIS and OECD publish their data, okay? Let me change first this to row, and I will go to the full later that I think is more interesting. We can add here also descendants or children, okay? So if I execute this, what I'm going to get is, like in SDMX, flat things, but of course, when we have an item scheme and the items are inside the item scheme, right? So we see here the agencies, because I said that we wanted to have the children's, okay? And we have the path location schemes. For each path location scheme, I see that the BIS is having this path location scheme with this ID and this version, okay, and a URN. And this includes these path locations, okay? So again, this has an ID, but there is a reference to an endpoint, which I would expect this is what most users are interested in, no? Right? Checking where can I get to the SDMX API and get data from the BIS. With this kind of query we do, okay, because I said children, and the endpoint, is a child of the path location, I can see here the actual implementation. So I say, okay, we saw here that the path location is using this endpoint, right? And I can find here this endpoint, and I get the base, the URL, and the implementation. So I see that there is a API version 1.40 with this extra URL, right, that supports the following formats and the following resources. Okay? And there is another implementation with the version 2.0.0, which changes slightly. Okay? So here I have all the information, but I would say that this is rather tricky for users to I mean, you have to join the responses of the request, right? So that's why we have this parameter that I think is very useful, and this is what Stratos was referring before, like something that is resolving things, right? So we are doing this work. So normally I would expect users to want to see the full detail. This means this we are resolving, we are going to the endpoints and the implementations. So here, if I ask, for instance, for the BIS and OECD, I see that BIS, in practice, for me, right, publishes in two places. In this URL here, stats.biz.org, well, only one, sorry, but it has two implementations, right, because this has this version 1 and version 2. But instead, the OECD, I chose the OECD because it's an interesting example, because they have two different places where they publish data, right? Because they have one for the current data and another one for the historical data, right? So you are going to be able to see here all the places, all the registries where you are able to go to get the data. Okay. The next one is about the endpoints, okay? So this, you see that the path locations are pointing to an endpoint. We are able also to get the endpoints. And again, we are following the same structure, right? We have the agency ID, the resource ID, and the version. Something important to realize, why do we have agency IDs in the endpoints and in the path location schemes? For me, in the beginning, this was shocking. And it's actually real cases that some agencies decide to publish their data in external repositories, right? Like, for instance, the global registry, right? So the agency for the endpoint means who is maintaining actually this physical thing that is the endpoint, right? And the path location is who decides that I'm going to put my data and metadata in here, okay? So if we try this out and we select, for instance, SDMX, okay, as an agency, and I'm going to select everything, so I'm going to see that SDMX is actually maintaining the global registry, right? What is interesting from here, and it is one of the questions Stratos was referring before, is that we can check for the parents. In this case, it's for the parents, not for the children, because this is going to tell us who is publishing data in the SDMX registry, in the global registry, right? So here, in this case, we don't have a resolver, right? So basically you say, okay, this is the endpoint, the global registry, and who is publishing here? The global artifacts by the SDMX, but also the IMF is having some publication in the global registry, okay? Of course, we can filter also by data, metadata, and other things, right? This is development mode, but it is almost there. But this is, I think it's showing the main ideas. And finally, let me show the interesting case for the URNs, okay? Here there is an explanation of what's going on behind, but I think it is also easier if we see it with a real example. The nice thing with URNs is that, as Stratos said, we already have all the information we need to understand where we can find these resources, right? So this is a very simple endpoint, right? We call the URN resolver, and we just provide a URN, right? As most likely all of you know, the URN is looking something like this. So there are several things that basically do their work, okay? It's not very relevant now. But at a certain point, we say, okay, here we are talking about category scheme. This is already relevant to us. Very important. This is a category scheme from the BIS, okay? So here is where we can do the first thing is, do we have in the GDS, do we know anything about where BIS is publishing data, right? In this case, it's yes, we know where BIS is publishing data. Second thing we know is we are talking here about category scheme, right? So we know whether it is data or metadata, right? So now we know, okay, where does the BIS publish metadata, right? And then we have here also the ID, right? This WebCat scheme in this case, and the version, right? So with this, if I execute this, we can parse this and we can extract all this information, right? So this is the kind of response that we have. So we are looking for a category scheme from the BIS 1.0 with this ID, right? And I can do, let me see if I can make it bigger because, okay, and we show here the query that we are actually doing, okay? Matt suggested that we should use the detail all stuffs to make the response shorter, right? Which I think is a good idea. And we are actually doing the query and we are returning the query response. So in this case, we see it's a 200, means that there was something there, okay? So this query is, here you are going to be able, if you do this query, you are going to be able to find this category scheme, or in general, the resource that you want to find. And of course, if it does not exist, for instance, just imagine that I wrote here a wrong version, okay? Then it's going to tell me, okay, the response is 404. We may not know exactly why we have a response different than 200, but this means that I'm not finding the resource where I was supposed to be finding the resource, okay? So as said, all these screens, you have them here as separate slides, but with this, thank you for the attention.
Thank you. I will just put again the QR code for the Slido. It's already open if anyone is connected. I think someone already answered. And we have time for maybe one question from the audience. Yes, do we have a microphone? I think the first one was the one in the back.
Hello, hi. Thank you for very nice presentation. That I think it's very useful. This is Wei Chen from IO. When I look your example slides where you present these very useful and complex queries that you can go, I just want to add one scenario that make it a little bit more complex. That recently it came up from one of our API users that and they have a question for me and I don't know how to answer, and then this is about data availability. So if you look at your third example where you want to know from OECD which data flows are available, and then if you add one more condition, which I think is very popular, where you want to look for a specific endpoint that all the available data flows for a specific country that has data. So our data wants to know, for this particular country, what is the list of data flows that has actual data? I don't know if it's possible today. If you're not pre-indexed or pre-scan all your data flows.
So yeah, thanks, Rachel. I think that at the moment this goes a bit beyond the current scope. For example, the current information we have, but maybe this could be GDS version 2, but for version 1 the scope is that let me know if you have availability queries, for example. But we're not going the next step and saying, okay, I'm doing the availability and I'm letting you know which are the available data for the data flows. But let's start with the basics, I guess, and we can get as complex as we see fit. And I think it will also depend on the demand, right? Thank you.
There are other questions? Yes, let's take one more, and then we will have a Q&A session with everyone.
Yeah, actually, I had the same question. Also, content queries. So, like, not only discovering the data flows, but like a question in the end of people saying, "Give me all the endpoint or the data flows on a specific subject with certain dimensions." But I guess you answered that already. So I have another question. So right now there are 4 data providers in the database as an example, and it's testing, etc. So what is the philosophy of maintaining this information if the number of data providers grows over time? And there are many in the world, and because it's quite detailed information, also modeling exactly the artifacts that are there, so the queries you can make. So what's the philosophy of maintaining this in future? Is this a task of the SDMX sponsoring organizations, let's say, or one of them, or should everyone do it? Is it a community approach? Something like that.
Thanks, Olaf. To start with, I would say it's not that much information because we don't store actually anything about the artifacts. The only information we store is the locations, and that's all, the endpoint. And the resolution actually is of the URN is nice because it contains all the information we need, and we just query live if this exists or not. I mean, there were proposals to probably deploy this GTS because this is supposed to be, let's say, driven like the global registry at the SDMX secretary sponsors level, let's say. But there were questions maybe in the future, should we also cache those requests, those artifacts, so someone would send the URN and then get back the artifact? Yes, no, I don't know. It's hard to tell. But yeah, for now, the information that is stored should be relatively low in volume. And yeah, if we have so many agencies we wish we have, yeah, we're happy to accommodate. Thank you.
Thanks again, Stratos and Antonio.
Should we?
One last round of applause. You can. Yes, you can stay here. I would like to invite all the presenters to come back. I will now try to show the results of the poll, all at the end. And probably you are not in the best placement to see the results because they are behind your back, but let's see what we can do. Okay, let me start maybe from the first one. And I think on this, Matt, you had a comment before, like to start having practical use cases even before implementation, and I have the feeling the audience has a similar opinion. Do you want to maybe comment?
Yeah, thank you. Yeah, so, you know, it's all very well and good having the theory of the changes in the model, but and the designs, but it's not until you implement the software that you start to tease out the problems. So one of the changes we made in the TWG was to say, well, actually, these things are not going to be in the standard until there is an implementation. Now, that doesn't necessarily mean that it's in the FMR or it's in .stat suite, but the core libraries have at least been updated to demonstrate the behavior works precisely as it should work, and therefore we're not going to release something and need to patch it in the future. So I think the no delay part would, in the core libraries, would be.
Thank you. And we had a similar question for tools, on which I see actually the distribution of the answer is slightly different, which I hope it's a good news for the tools producers.
Yeah, definitely. So with tools, you've got to start thinking about user interfaces and all these other things. So the delay is probably going to be slightly longer than immediate, but it should be faster because the core libraries support the functionality.
Thank you. And I don't know if, Brian, you want to comment on the results of our poll. the last one was actually more like a theoretical question, again on the same topic, if SDMX tools should support the new versions based on user demand or the other way around as a core principle. And I think the answer is, as always, depends. Not the one with most answers was the one, user demand has prioritization, but as a core principle, the tools should support it. If nobody has comments, I will just move on. You had the option to not to comment.
I selected the one with the 54%. It should definitely help prioritize, but you should try and support as many of the features as possible. Otherwise, what's the point of the feature? But I think from an API perspective, the REST API, I think the more coverage, the better. Because what's the point of an interface if you can't trust it to work, right? It's like, I'm querying for data from you, it doesn't work. But from you it does, and then you have to try and resolve the ways to work with this API and that API. So that's my answer.
We had then a custom structure definition. I can just give the microphone back. So your first question was on how in the organization is addressed the need of non-SDMX metadata support. Is it surprising? I would say probably not.
No, I mean, at the end of the day, if people have requirements and they're going to solve them with the capabilities that are given to them. And at the moment, SDMX has annotations. It says, if this doesn't fit your use case, just do this. But it's it's not just non-standard, but it's a free-for-all. So therefore, you have to start then standardizing on what the annotations are if you want to reuse them. So that's not a surprise to me. And it's what the custom structure definitions are there to try and solve.
And I guess then this question was about the use cases.
Yeah, well, this is encouraging. I'm glad we didn't put not applicable in there. So everyone has a use case, which is brilliant. Dissemination, visualization, that was the primary purpose, I guess, but it's nice to see there's other use cases as well, which people want.
And there was one more question, because other was not possible to leave in free text, so I set a separate question, and I didn't have time to see. We got 3 replies, actually, for additional use cases for custom metadata.
Okay, well, I mean, on custom metadata, it's there to solve use cases which are specific to an organization because an organization wants to do something on their website or internal process. The dimension constraints is actually a problem which is, I think, a universal. I mean, maybe even Abdullah wants to comment on this. But yeah, the dimension constraints impacts things like how the schema is generated and other things like this. So it needs to be in the standard. Additional use cases. Okay, I'm not sure I have anything to say.
Thank you. I would like to comment on the first one. I think the idea of the CSD is exactly this, to have this overlap. For example, imagine that we are using code lists, but we want to add, for example, validity period for codes, right? We would implement this in the CSD, but if we are not the only ones, and then all the other organization supports it, then it should go to the standard. This is what Matt was saying. So, yeah, maybe dimension constraints were already into the standard because apparently we have discussed and agreed that, yeah, this is a very common use case. So I think that this is exactly the reason why we proposed and we intend to implement the CSD.
I will quickly move to the REST API survey. Can you maybe pass the microphone to Seb? Yeah, in case he wants to comment. So there is an interest, yes.
Yeah, no, this is great news. We knew there was there was some interest, but it's nice to have the confirmation.
Yeah, this could be a prompt maybe for a more precise survey on exactly which features is the interest in. And the second question?
Okay, yeah, that's also good news. Not being big fan of GraphQL, which is good news.
Good, and I quickly move on to the last set of questions, and then we can open the floor as GS implementation. Yes, I don't know, Antonio or Stratos, if you want to have them. I guess this is not surprising. Yes.
Just to verify that we are doing something that is required by the audience, and apparently it is.
And the endpoint discovery.
Interesting, yeah, the endpoint discovery. Now, this has been discussed in the TWG, and maybe we need to explain this a bit better, because I think that the idea and how we oriented the API was mainly for the first one, to be fair, so the location. And I know it's not easy, having seen just an information model and just a very short presentation, to understand the difference between the two. But we thought that the primary objective is to give you the actual point that you would find something for the BIS, for the OECD, for Eurostat, and not really the physical implementation. Of course, the physical implementation is part of what we're giving you, but maybe it depends on what the client anticipates. This is, let's say, if the client, and here the client is another system, wants to maybe catalog all the endpoints, yeah, it makes sense. But if the client really is concerned about the allocation of the different metadata from the agency point of view, then I would say the first would be the objective. But
well, I think as well, if as it was only just introduced locations and endpoints, I imagine there may also be confusion between.
There was one last question on missing from the Global Discovery Service.
Okay, yeah, so I think that the idea is to go to the next level and really provide a central, not only discovery, but really retrieval service. I think this is pretty much the idea here, to go a step further. And just to give you a very short history of how the GDS came into life, was our very, very long discussions in the TWG about federation of registries, which was supposed to be, I have a distributed, let's say, environment. I have 10 registries around the globe, and then we would like to be able to have those registries communicating and really getting all the information, maybe from any entry point. It was deemed too complicated and a bit of a burden to really implement these to any registry, and of course, also depends on the willing of the different registry vendors, let's say, or web services to do that. So that's why we thought we came with this more centralized approach. But I think it's good to know those use cases and, yeah, take the next steps for GTS. Thank you.
Thank you. So this concludes the discussion on the Slido, and I think I can open the floor for questions. We have 15 more minutes. We have a question here. Is there maybe a microphone for the audience so that we can keep one here? But first here.
So just a question on the Global Discovery Service. So at the IMF, we maintain our agencies down to the department level. So when we publish, we'll do imf.sta, imf.research, and we also have IMF just by itself. Is the idea that we're going to have to register all of these agencies in the Global Discovery Service, or can we leverage the fact that we're using a hierarchical agency scheme and not have to duplicate, and whenever we get a new department, add something to this system that people may not be thinking about as the first thing on their minds?
The initial idea was exactly to have a detailed representation of what you're publishing, because maybe you also have internal structures that you don't care. But I mean, if there is a demand to have this level of functionality, it should be relatively easy to implement, because if you have the root level IMF, then it could be just a switch to say, okay, just propagate to anything under the agency, because it's easy to discover. But for example, if you have cases like BIS is publishing in specific registry, but then BIS.med reports publishes some code list in another registry, then it might make sense to differentiate.
But I think it's a good use case.
I think that one has to consider the meaning of path location and the endpoints, right? I think in this case we would be talking about path locations, and the idea here is that there is an organization, an agency that decides I'm going to publish here. I guess that it is the IMF, it's not these departments who take these decisions, right? I guess in that case, I think it would make sense that there is only one path location scheme, right? Then maybe, I don't know, but if, for instance, you have different endpoints per department, I don't know whether that's the case, okay. In that case, you may need different path locations, but, sorry, endpoints. But again, the endpoint has a meaning as well. Who is maintaining this endpoint, right? Who is responsible to make sure that it is up and running and so on? So again, if it is the IMF as a whole, then it should be IMF, right? A different thing is that the artifacts may belong to a sub-agency or something like this. But the meaning of the agency idea, at least for me, Stratos, I don't know what you agree, is exactly that. Who is responsible for this path location or for this infrastructure endpoint?
So I have one question to Abdullah and one to the group, maybe more to Matt. Regarding the new feature or foreseen feature on the vertical complexity that you presented, it's something that would be, as you mentioned, useful also in case of data exchange initiatives by allowing us to, global data exchange initiatives, by allowing us to start with smaller DSDs and maybe add dimensions later on as they become relevant. But you were mentioning also that it solves the difficulty of having different dissemination and reporting DSDs. Just to make sure that I've understood the scope of the feature. I see how it can work in resolving the difference between reporting and dissemination. In case, in dissemination, you only want a subset of a dimension, right? Or a subset of dimensions. You want to only show breakdown by sex and age and not all the other breakdowns. But I didn't really understand if it also aims to solve the issue that in dissemination sometimes you tend to, once again, recreate composite dimensions more to solve, let's say, the issue of the data cube being very sparse and not necessarily looking very good or being easy to browse if the dimensions are separate. It seems to me that this use case is not addressed in dissemination by your proposal, or this difficulty in combining reporting and dissemination DSDs in a single framework. Am I correct, or did I misunderstand? Is there some feature that I'm not seeing?
Yeah, thanks, Luca. You know what? I'm not sure how to answer this, because my thinking was always that in the case of dissemination, the issue is that you need to unmerge mixed dimensions instead of merge split dimensions. What are the requirements for dissemination? You want to pivot your data. You want to have clean dimensions. You want to have a limited number of dimensions, right? And you want to have dimensions which are easy to visualize. Merged or mixed dimensions like composite breakdown or custom breakdown, or even simple merged dimensions like the series in the SDG DSD or indicator in the ECOFIN DSD, they're very difficult to visualize. If you have a composite breakdown, there isn't even a column that you can assign a label to, because it can vary. You have different breakdowns, and therefore you can't even assign a label to the column because the label will vary as you go down. In the case of custom breakdown, that's a complete nightmare. That's even worse, because you don't even know the meanings of the labels until you process the data set. You can't even get that from the DSD. So I think that in the case of dissemination, the reason that, for example, I base my experience on the SDG DSD, the reason it's so poorly suited for dissemination is precisely that. Precisely the presence of these mixed dimensions, which are not good for visualization. There are other reasons as well, but this is the primary reason. So in my mind, it's always, when you visualize, you unmerge dimensions instead of merging them. But to answer your question, what you will have is you will have clean, I mean, I would expect that you would have clean code lists and pure concepts. If you want to merge them automatically, I think that this is not directly addressed by this, no.
Clear, thank you.
But the point is to eliminate the need for those mixed dimensions in the first place.
Okay, thanks for clarifying this, Abdullah. At least we have use cases where dissemination wants more composite things, but clear. Your answer was very clear. And then the question to Matt and to the group a bit. I was looking yesterday at the presentation by our Belgian colleagues, how they were taking the code lists and adding translations, which obviously meant that they had to create a local copy of the code list, and they lost the synchronization, let's say, with the original SDMX code list that they were using because they wanted to add some translations or add some annotations. And I think you mentioned, Matt, yesterday at some point, maybe we could think of having a code list composition concept where you can just extend an existing code by some multilingual label or some annotation, because right now with the code list composition that we have, which is already quite useful, the codes that you take them as they are, and then you can add new codes on top, but you cannot add properties to the previous codes. And it wasn't clear to me if this is just an idea that came to you yesterday, or I mean, is there some discussion already in the TWG about this feature? Or is it foreseen somewhere in the pipeline, or is it just, it was just something that you were proposing a bit on the spot?
No, so this was my, this was when I was presenting on the entity thing. Yeah, okay. Yeah, I mean, there's something on the TWG backlog, not backlog, on the issues board. So a member of the public has created an issue, and they've said, for example, why do we have to have all of the localizations of names and descriptions within the same code, and can't we kind of just kind of attach things to a code? So there is something on the issues backlog, but in the context of my presentation, it was kind of, you can't take a code list now and extend it to augment it. You can't do that. So I could take a country code list and I can extend it to add maybe international organizations, that's fine. But I can't take a country code list which is in English and then say, now these are my French labels, because you've got to repeat all the IDs and then you've got to put the labels in. You basically just recreated the code list, right? And there's no way of saying, well, I've recreated that code list by adding these labels, and those labels come from that thing over there. And even if you could, you'd have hundreds of code lists for labels. So that was the point of the entity model, was just to say, well, look, everyone's talking about just this entity called France. Why can't we just attach all the different localizations of that to that entity? And then when you create your code list, all you need to provide is the ID, FR, DE, UK, US. You point it to the entities, and if somebody wants your code list in German, they then say, we want to take your code list, go back to the entities and get all the German labels for those entities. That was the idea.
Yeah, thank you. Just about that, Matt, there is an issue that I think it was initiated by David. It has to do with horizontally extension of code lists that deal with all this stuff. So I think it was one of the features that we couldn't release in SDMX 3.0, and I think that we have to go back to the old papers. But anyway, the comment I want to do is about the SGDS and the question about whether we have to publish or not all the endpoints and all the publications. And as Stratos said, the SGDS is the result of years of informal conversations about federation of registries. And I think that the main use case, despite a lot of new features that has been already added and others that will come, is to be able to use shared code lists on the fly without having to have local copies. Because even with the global registry being a shared repository and a source of truth for and a number of artifacts, today we have to have copies of that in our own registry because we don't know what is the location of one specific artifact when you are processing it. So the idea of the HDS is that you will have, just by knowing the maintenance agency of, for example, a global code list, you will be able to know where to look for that. You may have copies for performance reasons, but at least you know where the original one, the master one, is located. And that was the initial use case. And I think that taking that into consideration, the decision of which endpoints to publish or not is from each agency. At the moment of registering for the HDS, that is a process that we have to be developed in order to have all agencies that has artifacts that worth being shared or data that worth being shared and discoverable registered for that service.
I just want to say something about this. I have been in some data collection and data production environments in organizations, but for some time, and especially with SDMX, I'm coming more from the user side. And I really think that we should also think about users, right? Not only about why do we have data users, right? Why do we have this? I think, Edgardo, your case is more for organizations, right? I want to refer to a code list and I don't want to keep it, or I want to make sure that I know where the copy is, and so on and so forth. But I think that as statistical organizations, one way or another, there is a lot of work that you are doing, and I guess this is in order to have final users actually using the data. So I think, for me, in my mindset, the main use case is users, right? I want to know, and I had problems in the past. I have tried to use data from some organizations, and I really struggled to find these registries, these SDMX APIs where they were. So I really think that we should focus also, we should add this use case, right, to the use case that you as organizations should have. I think it is a great incentive for all organizations to say, okay, I have an SDMX API, and I will add it here because that's the way I will have more users. More users are going to know that I have this data, and they can access it in this way.
I fully agree, but it's not exclusive for that. I was just trying to tell what was the origin of that service, and basically the same that applies for structured metadata applies for data. You decide whether your data is to be published or not. That was the final goal.
Okay, I'm sorry to have to stop now, but maybe also glad to have to announce that there will be the lunch break, and thanks a lot to our great colleagues who presented today.